Let's look at a problem similar to 13. Mary and Larry left the riding stable at 10 a.m. Mary trotted south, so then I'm going to draw the picture so that she trots south at 4 miles an hour, or sorry, 4 kilometers an hour. Larry galloped east at 6 kilometers per hour. To the nearest kilometer, how far apart were they at 11:30? So then I'm looking at the start time and the end time. They were on the road for 1.5 hours. And just like stoichiometry in chemistry, the units here will cancel. So when I multiply, I'll know exactly how far each traveled. So if I take 6 times 1.5, that's 9. If I take 4 times 1.5, I get 6. And then I have to figure out how far apart they were. In other words, what's the distance from there to there? So that makes a right triangle, which means I'm going to use the Pythagorean theorem. So I have 6, 9, and whatever this is, the distance. I can factor a 3 out of there and use the reduced triangle principle. Then this distance would be 3 times x. So now 2 squared plus 3 squared equals x squared. 4 plus 9 is x squared. That means my x is the square root of 13. But remember, my distance that I need is 3 times that. So I know they were 3 times the square root of 13 kilometers apart. If Moodle were looking for an exact answer, and it's not because it says to the nearest kilometer, but if it were looking for an exact answer, remember we're using the Excel notation, we would enter that. 13 square root times 3. So roughly to the nearest kilometer would be 11. And since that's what Moodle asked for, I would just put in the 11. The kilometers is already written.